So let's start with a process that you've probably seen before, or I would assume most of you have. This is propane gas. So we go outside and barbecue in the summer, and it's going to mix with oxygen gas and release carbon dioxide and water. This is a combustion reaction. So we're definitely going to have heat in order to make this happen. And let's add in our phases. Gas, 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 water. Cool. How on earth are we going to balance this? Because what this says is I have 3 carbon atoms mixing with 8 hydrogen atoms to make my propane molecule, plus oxygen in its diatomic state. But I'm only going to get out 1 carbon on this side. So remember, conservation of mass says that I can't get out less than I put in, and I certainly can't get out more than I put in. So what we need to do in balancing is make sure that we have the checks and balances of how much do these things actually go together proportionately. The best way to start that is to say, okay, so let's start a table. We have carbon and hydrogen and oxygen on this side, carbon, oxygen, and hydrogen on this side. But at least we know that's correct. We have 3 here, 8 here, 2 here, 1 here, oops, that's going to be a problem, 2 here, 2 here, oops, forgot that last oxygen. Actually, we'll go ahead and treat them separately, and 1. So I actually have 3 oxygen on this side, and only 2 on this side. So the one thing I can start off with is knowing that no matter what, this is going to have to increase. The 3 over here to the 1 over here, I know this has got to increase. So we know it's at least going to be a 3. So if I multiply this by 3, what do I get? I get 3 carbon, and then 3 times this 2 gives me 6 oxygen. And then this hasn't changed. We're still 2 and 1. Let's draw a little line. Keep this neat. Alright, so now let's see what we're up to. I have 3 carbon, good. I have 7 oxygen, and only 2 here. So that's got to be fixed. And I'm leaving that alone for a reason. You'll see in a second. I have 8 hydrogen and only 2 here. So minimally, because this is the only place that hydrogen shows up, let's multiply our water over here by 4. And what do we get? I get 4 times 2 in this compound gives me 8 hydrogen. Okay, looking good. And then 4 times this oxygen gives me 4 oxygen. Okay, so now I have 3 carbon, 6 here, and 4 here, so 10 oxygen altogether. But that's an easy fix. I look over here, multiply 5 by that, that makes that 10. Cool. I have 8, actually let me rewrite this so it's a little neater. There we go. So it's not confusing, so we're not thinking we're adding more into it. So 3 we're good, 8 we're good, 10 we're not good. So the only thing actually that we need to tinker around with is we need 10 oxygen. So we'll leave this guy as it is, the 3 and the 8, and we'll multiply this by 5, and we get 10. So we multiplied this by 4. We'll do the equal sign so we know. So if I add 4 here, I end up with 8 hydrogen and 4 oxygen. Leave this alone. I just multiplied 3 by that, so let's rewrite what we have because it's sure looking good. So we left the propane alone, C3H8 gas plus 5 O2s to give me my 10. A little bit of heat, and I said 3 carbon dioxides. So 3 CO2, CO2, and that's a gas, plus I multiplied 4 to increase the water count, 4 H2O. So let's see. Let's do a quick double check of our work. 4 times 2 is 8 hydrogen. 8 hydrogen, good. I have 10 oxygen, and over here, 10 oxygen, good. 3 carbon here, and 3 carbon here. I am balanced. So this is good. And that is, in the nutshell. So the only thing I would say I would do differently to make it a little bit neater for myself is to maybe do a little equal sign. Or we could even do a column. However you want to do it, to kind of keep track of when you're changing your coefficient, so you know that I'm adding or multiplying this compound by 3. So brief kind of go back a little bit. When we're balancing equations, the one thing we can't do is change any of these subscripts. The only time we can change those subscripts is when we're going back to the periodic table and figuring out how two things to go together, like the sodium chloride. Then we monkey with the subscripts to see how things go together. But once that's been established and we know how our molecules are put together, those subscripts do not get changed. The only thing we do is add some sort of coefficient in front of our molecules to figure out how many pieces of them go together. So what this says in short is that for every 1 propane molecule, I need 5 oxygen molecules to react together, and I will get 3 carbon dioxide molecules and 4 water molecules. So this is your recipe. Cool.